Okay, this is part 1 of section 3.4, solving rational equations. When we're speaking of rational equations, what we're speaking of are fractions involved in an equation. Okay, so x could be in the numerator, it could be in the denominator, it can be in different places. But anyway, a rational equation is an equation that deals with fractions where the variable, right, the unknown, can be part of the fraction. Okay, so I want to work through a few examples just to kind of get a general idea of what's going on here. So our first example, we have 1/3 minus 1/6. Let's say 5/6 instead. And that equals 1 over x. Okay, we need that x there so we can solve it, of course. Okay, and so the general strategy will always be to look at the denominators, right? We have 3 different denominators here, 3, 6, and x. Okay, and I usually like to take the numbers together, like 3 and 6, and think about what would the common denominator for those be. That would be 6, right? Common denominator for the numbers would be 6. All right, and then if there's an x, you definitely need to include an x, okay? If it were x squared, you'd want to include an x squared. You have to cover that unknown term since we don't know what it is. Okay, so 6x would be my common denominator. I'm going to multiply all of my fractions, well, all the terms, by 6x. Okay, so let's see. This is going to be 1/3 times 6x minus 5/6 times 6x equals 1 over x times 6x. Okay, and when you do this, it's going to clean up the equation. Clean it up a good bit. Okay, because if you think about this, 6 divided by 3 is 2. So we can say they cancel each other out in a way, right? That and that cancels. It leaves me with a 2. This 6 and this 6 cancels out altogether. It leaves me with a 1, but you know 5 times 1 is just 5, so you can leave the 1 off. Here x and the x will cancel out. So what does that leave me with? That's 1 times 2 times x. That's 2x. 5 times x. That's 5x. Equals 1 times 6 is just 6. So that's negative 2x minus 5x equals 6. That equation is a whole lot easier to deal with than the original. 2x minus 5x, if I combined my like terms, would be negative 3x. Divide both sides by the negative 3. And that leaves me with x equals negative 2. Okay, now with these, because we're moving things around and we're doing a lot of manipulating, you want to check your answers to make sure that what you're getting are not false solutions, okay? Extraneous solutions, as they're called. Okay, so what I'm going to do is plug in negative 2 into my original equation. So let's see, 1/3 minus 5/6 is equal to 1 over negative 2. Okay, that's what we want to be true if this is a solution. Okay, I need to rewrite this right here so I can actually do that subtraction. 1/3 is the same as 2/6, right? Just multiply the top and the bottom by 2. And then 2/6 minus 5/6 is going to be negative 3/6. And I can simplify that, right? Negative 3 over 6 is negative 1/2. Okay, so there we go. Negative 1/2 is the same as negative 1/2. Okay, even though the negative's down here at the bottom, we know that means it's just a negative fraction. Okay, good. So negative 2 is our solution. Okay, let's do another example. Okay, example 2, we have t plus 1 over 3 minus t minus 1 over 2 equals 1. Okay, this is a rational equation, but notice this time we don't have any variables in the denominator, so that kind of makes it a little easier. All we're going to focus on are the common denominators. Okay, so we see 3 and 2. This one technically has a denominator of 1. You can kind of ignore that though. 3 and 2 both go into 6, so 6 will be my common denominator. That's what I'm going to multiply everything by. So t plus 1 over 3 times 6 minus t minus 1 over 2 times 6 equals 1 times 6. Okay, and you do want to be careful here in understanding what you're doing. Really, this is t plus 1, that's all times the 6. Okay, so make sure that you kind of at least understand that. Okay, so like before, we're going to simplify the numbers first. So 6 over 3 is 2, right? 6 divided by 3 is just 2. So this is just 2 t plus 1 times 2. Yeah, I like to write the 2 in the front though, right? We're used to seeing it like that. Okay, minus 6 divided by 2 is 3. So that's really just t minus 1 times 3. Okay, and then 6 times 1, of course, is just 6. Okay, again, here's an easier equation to deal with. Distribute the 2. 2t plus 2. Distribute the negative 3, right? This is a negative 3 minus 3t plus 3 equals 6, okay? Combine like terms. 2t minus 3t is negative 1t. Positive 2 plus 3 is positive 5. Equals 6. Okay, subtract 5 from both sides. 6 minus 5 is 1. Understood, negative 1 right here. Divide both sides by negative 1. I get negative 1. Okay, so negative 1 is probably my solution. We need to go and check it. So negative 1 plus 1 over 3 minus negative 1 minus 1 over 2 equals 1. Okay, well, negative 1 plus 1 is 0, so it's 0 over 3. Negative 1 minus 1 is negative 2, so it's minus negative 2 over 2 equals 1. Okay, this is 0. Just leave that off. Minus a negative is a positive, so it's positive 2 over 2, which is just 1, equals 1. Check. All right, good. It works. So negative 1 is my solution. All right, let's do a little bit more complicated example here. 2 over x minus 1 equals 3 over x plus 2. All right, so now this one's trickier, okay? Notice x has something attached to it, right? It has subtraction, minus 1. On this one, x has plus 2 attached to it. So I need to deal with each of these individually, okay? Well, I'll say individually. I need to take each denominator, each unique denominator into account. So what do I mean by that? Right here is x minus 1. So I want to make sure that I account for x minus 1. Right here is x plus 2. I want to make sure I account for x plus 2. So this right here is my common denominator. So 2 over x minus 1 times x minus 1, x plus 2. Okay, I just put the two denominators together. Equals 3 over x plus 2 times x minus 1, x plus 2. Okay, so by doing this, the x minus 1s will cancel here to leave me with 2, x plus 2. The x plus 2s will cancel here to leave me with 3, x minus 1. That's much easier to deal with because now I just distribute the 2. I distribute the 3. Okay, now it's a regular old equation to solve, right? I'm going to subtract 2x from both sides. Let me write this out. I'm going to subtract 2x from both sides, so I cancel it out on the left. That's going to bring my x to the right side. So I need to get rid of this minus 3. So I'm going to add 3 to both sides. So this cancels, and that cancels. 3 plus 4 is 7. 3x minus 2x is just x. So 7 is my potential solution. Let's go and check it. Two over 7 minus 1 equals 3 over 7 plus 2, hopefully, right? 2 over 7 minus 1 is 2/6. 3 over 7 plus 2 is 3/9. 2/6 reduces to 1/3. 3/9 reduces to 1/3. So there we go again. 7 is our solution. Okay, next example. X minus 12 over x equals 1. Okay, so this one's a little different. Let's see how it's going to be different. So first, let's deal with the fact that we have an x in the denominator. Since it's my only denominator, it's going to be my common denominator. Okay, it's the only one. So I need to multiply everything by x. So x times x minus 12 over x times x equals 1 times x. Now the only denominator that's going to cancel out, of course, is here, the only denominator that we have. So this simplifies. X times x is x squared minus 12, all right, that's all that's left here, equals 1 times x is x. All right, this one's different because we end up with a quadratic. And by now we should know that when you end up with a quadratic, you end up with up to 2 solutions, okay? 2 solutions. Okay, so how do we solve a quadratic? We get it all set equal to 0. So I subtract x from both sides. Okay, so I subtracted x from both sides. Make sure you put it in order, right? Remember, quadratic's in the form ax squared, x squared's first, plus bx, plain x is by itself, or its second, plus c equals 0. C is the constant, and then 0. So make sure you put it in the right order. Okay, then you can factor it. You can use the quadratic formula. This one's not too hard to factor. Remember, you can go back and review how to factor. But x minus 4 times x plus 3 equals 0. Remember, the zero product property says that I can take each of these and set them equal to 0. Add 4 to both sides, I get 4. Subtract 3 from both sides, and I get negative 3. Okay, so I have 2 potential solutions. Now, especially when there's a quadratic, you have the potential for extraneous solutions, right? Remember, those are solutions that are not real solutions. So I need to be very careful here. 4, and negative 3. Let's plug them in. So let's do 4 first. 4 minus 12 over 4 equals 1. Well, 12 over 4 is 3. So this is 4 minus 3 equals 1. Oh yeah, 1 equals 1. That one works. So 4 is good. Let's check negative 3. Negative 3 minus 12 over negative 3 equals 1. So negative 3 minus a negative, right? They become positive, so that's going to be plus 12 over 3 is 4 equals 1. Negative 3 plus 4 is 1. 1 equals 1. So it turns out that negative 3 is also a solution. We do not have an extraneous solution this time. Okay, let's do a few more. Example 5. Three over m plus 2 plus 2 over m equals 4m minus 4 over m squared minus 4. All right, so here we go. This is a pretty complicated one. Okay, and so what we're going to do is first, let's see if we can simplify the denominators at all. In other words, can I factor that? And yeah, I can factor. M squared minus 4 is difference of squares, so hopefully you remember that that is, try that again, there we go. That is m plus 2, m minus 2, right? Remember, difference of squares. Something squared minus something squared. You take the square root of each part, put a plus and minus in between. Okay. Now, let's look at all the individual components of the denominators and see what our common denominator is going to have to be. Okay, our common denominator will have to have m plus 2 in it. Our common denominator will have to have m. Our common denominator has to have m plus 2 and m minus 2. Well, I already have the m plus 2, so I don't have to put that again. M minus 2, though, I need to add in. Okay, so this is going to be my common denominator. Now, the order that I put these don't really matter. I just put m first because it's only one term, so I like to put that one first. Okay, but that's my common denominator, so that's what I'm going to multiply everything by. If you're writing this down, this is usually hard to fit on one page. So write small or turn your paper sideways or something. Okay, so 3 over m plus 2 times m plus 2, m minus 2, plus 2 over m times m plus 2 times m minus 2 equals 4m minus 4 over m plus 2, m minus 2. Remember, that was m squared minus 4 times m plus 2, m minus 2. All right. Now we'll cancel stuff out and clean this up. On the first one, m plus 2 will cancel out. On the second one, m and m. On the third one, m plus 2, m minus 2. Let's rewrite it. 3m m minus 2 plus 2 m plus 2 m minus 2 equals 4m minus 4 m. And I'll put this in parentheses because that 4m minus 4 is all together multiplied times m, right? All this is part of the fraction that's times m. Okay, let's see what we can do. 3m times m is 3m squared. 3m times negative 2 is negative 6m. Before I distribute the 2, I'm going to multiply this back out. Remember, if I did difference of squares, that's m squared minus 2m plus 2m minus 4 Of course, these two, if I combine those like terms, they would cancel out because negative 2m plus 2m is 0. So I'll be left with m squared minus 4, right? That's where all that came from. So let me actually just clean it up and say m squared minus 4 equals m times 4m is 4m squared. M times negative 4 is negative 4m. Okay, got to distribute a little bit more with the 2. So 2 times m squared is 2m squared. 2 times negative 4 is negative 8. All right, so there we go. It's not a rational equation anymore. It's a quadratic now, right? We're dealing with m squared. All right, let's combine like terms. So 3m squared minus, or plus 2m squared is 5m squared. Negative 6m is by itself. Minus 8, that's by itself also. Okay, so now subtract 4m squared from both sides, right? If it's a quadratic, we need to get that right side equal to 0. Add 4m to both sides. That'll take care of the right side there, because 4m squared minus 4m squared is 0. Negative 4m plus 4m is 0, so the right's 0. 5m squared minus 4m squared is m squared. Negative 6m plus 4m is negative 2m minus 8. All right, we have a nice, simple quadratic equation to deal with. All right, remember what this looked like in the beginning. All right, let's go back. It looked ugly, right? This is our equation. Now we're dealing with a quadratic, which we have experience solving. Factor it, okay, or quadratic formula, or whatever you prefer. Okay, two numbers that multiply together that give me negative 8, but add up to negative 2 would be negative 4 and positive 2. Zero product property says I can set them both individually equal to 0. So I get two solutions, or at least two potential solutions, 4 and negative 2. 4 and negative 2. Okay, let's test them out. Okay, I'm going to just rewrite it down here at the bottom. So the original problem said 3 over m plus 2. Let me go ahead and plug in a 4. So 4 plus 2 plus 2 over 4 equals 4 times 4 minus 4 over 4 squared minus 4. That's 3 over 6 plus 2/4, which is 1/2, equals 4 times 4 is 16, minus 4 is 12. 4 squared is 16, minus 4 is 12. Okay, so 3/6 is 1/2, plus 1/2 equals 12 over 12 is 1. 1/2 plus 1/2 is 1. 1 equals 1. Check. All right, great. 4 is a solution. Let's try it with negative 2. So negative 2 plus 2 plus 2 over negative 2 equals 4 times negative 2 minus 4 over negative 2 squared minus 4. Negative 2 plus 2 is 0. Running into a problem here. 2 over negative 2 is negative 1. It's going to be negative 8 minus 4 is negative 12 over negative 2 squared is 4 minus 4 is 0. Okay, I'm dividing by 0, right? Especially two places. So this one's no good. So in other words, we cannot say that negative 2 is a solution. There's an example of an extraneous solution. All right, let's do two more examples. Two x over x plus 7 equals 5 over x plus 1. Okay, at least this one looks a little bit nicer here. I have two denominators, so I'm going to multiply both sides by x plus 7, x plus 1. Okay, so x plus 7, x plus 1 equals 5 over x plus 1 times x plus 7, x plus 1. Okay, those are my two denominators. Put them together, multiply both sides, so that I can simplify that side. Left side's going to be 2x times x plus 1. X plus 1 cancels here, leaving me with 5x plus 7. Distribute. Okay, and now I have a quadratic equation again. Okay, quadratic equation, I need to get the right side equal to 0. Try that again. There we go. Need to subtract 35 from both sides. (2x minus 5x is negative 3x. Minus 35 is the constant. It's going to stay on the left side. And it equals 0 because all that canceled out. All right, so now I can use the quadratic formula. I can try to factor it. In this case, I would have to use the AC method, or trial and error. I'm just going to guess some numbers here because I know I have to have a 2x and an x, right? That has to happen in order to get 2x squared. Now I have to find something times something that will give me negative 35. And so what comes to mind would be negative 7 and positive 2. Okay, so now that's not officially my factored form. I'm going to test it out here. 2x times x is 2x squared. 2x times 2 is positive 4x. Oh, I don't know why I said 2. That should be a 5. There we go. All right, 7 times 5 is 35, not 2. Okay, 2x times x is 2x squared. 2x times 5 is 10x. Negative 7 times x is negative 7x. Negative 7 times 5 is negative 35. And then I compare that to the original. If I combine these like terms, I would get a positive 3x. This is a negative 3x. Okay, so I know that's not right. The only thing wrong, though, is the sign. So that means all I have to do to fix it is change my sign, or my signs. So instead of a minus and a plus, I'll do a plus and a minus. Okay, and so now it's factored. Zero product property. Set both parentheses equal to 0. On the left, I'll subtract 7 from both sides. And then I'll divide both sides by 2. Negative 7 over 2. On the right, I will just add 5 to both sides, and I'll get x equals 5. Okay, and then I will check them. Instead of checking it by hand, I'll just use the calculator, which is what I would expect you to do anyway. I'll write it, and then I'll type it. Although you won't be able to see the typed version of it. But I'll type in exactly what I'm writing. So 2, negative 7 over 2, over negative 7 over 2 plus 7 equals 5 over negative 7 over 2 plus 1. Okay, so that's what I'm going to type in. 2, negative 7 over 2 over negative 7 over 2 plus 7. The left side comes out to equal negative 2. 5 over negative 7 over 2 plus 1. Right side comes out to be negative 2. Check. So good. This negative 7 over 2 is a solution. Okay, let's plug in 5. 2 times 5 over 5 plus 7 equals 5 over 5 plus 1. Okay, so in my calculator, 2 times 5 over 5 plus 7 comes out to be 5/6. And you can actually see that without me typing it in, right? 5 plus 1 is 6, so that's going to be 5/6. Check. So both of these solutions are good. Okay, and so I wanted to use the calculator because it's quicker, especially dealing with those fractions. And the next example, the calculator may come in handy. So let's do the last example for this part of the section. Okay, I think I'm on example 7, right? Yeah, that was 6. Here's 7. Okay. So here we go. We have 1 over 4x plus 12 minus 1 over x squared minus 9 is equal to 5 over x minus 3. All right, so this is going to be a pretty ugly one, I can already tell. Let's simplify each of the denominators before we worry about finding the common denominator. What I mean by that is I can factor out a 4 here. Okay, this is difference of squares, right? That's x squared minus 9, or 3 squared. So that's going to be 1 over x plus 3, x minus 3. And then x minus 3 on the last one is going to stay the same. Okay, so my common denominator has to have a combination of all these. The first denominator is 4x plus 3. So I definitely have to have a 4x plus 3. This one has an x plus 3 and an x minus 3. Now I already have the x plus 3, but I need the x minus 3. This one has an x minus 3. I already have an x minus 3. Okay, so that's going to be my common denominator. 4x plus 3, x minus 3. All right, I'm going to write small so that I can fit this. 4x plus 3x minus 3 minus 1 over x plus 3x minus 3 times 4x plus 3x minus 3 equals 5 over x minus 3 times 4x plus 3 x minus 3. All right, so I'm going to raise that up, give myself some more room to work. Let's cancel some stuff out. 4x plus 3. I'm left with 1 times x minus 3, which of course is just x minus 3. Minus x plus 3, x minus 3. I'm left with 1 times 4, which of course is just 4, equals x minus 3 cancels. I'm left with 5 times 4, 20, times x plus 3. Okay, that's not even a quadratic. That's a pretty simple equation to solve here. Distribute the 20. Well, left side, let's combine like terms first. Negative 3 minus 4 is negative 7. Distribute the 20. Okay, let's subtract 20x from both sides. And let's add 7 to both sides. And so we can cancel that out and cancel that out. Negative 19x equals 67. Divide both sides by negative 19, and I get negative 67 over 19. Oh, I should check that first. All right, so that's going to be fun. I promised calculator was going to be helpful here. This is why. So 1 over 4 times negative 67 over 19, not 12, 19, plus 12, here we go, minus 1 over negative 67 over 19 squared minus 9 equals 5 over negative 67 over 19 minus 3. All right, so I'm going to type this in the calculator. 1 over 4 times negative fraction 67 over 19 plus 12 minus 1 over negative 67 over 19 squared minus 9. Okay, the left side comes out to be negative 95 over 124. Okay, don't want to do that by hand. The right side, 5 over negative 67 over 19 minus 3 comes out to be negative 95 over 124. All right, check. So negative 67 over 19 is my solution. Okay, and so there we go. That is the first part of section 3.4, solving rational equations.